Hello, welcome back to Cracking the Cryptic, and a puzzle with a bit of line interaction here. So get your glasses out so that you can see that sometimes the line is blue, sometimes it's yellow, and sometimes it's both in this. We'll look at the rules in a moment. They're very interesting, and can't wait to see how these lines interact. It's a puzzle by Half-Baked Lunatic, who hasn't featured on the channel in a long time, who does feature regularly in our apps. So do check out Line Sudoku, which features some Half-Baked Lunatic puzzles, as do some of the others as well. So if you enjoy this one. And the other apps are really fascinating too. We've got Fog of War, of course. We've got the Worms lately. James Sinclair and Marty Sears have provided some consequential puzzles that are really good. And we urge you to have a look at those. They will be great fun. And as well as our apps, you can find your way to SVEN'S SUDOKU PAD and support that in the links under the video. There are also, of course, links to our Patreon site, where the Labours of Rostam hunt is closing on the 20th. So get your answer in by 4 p.m. our time that day if you want to win the possible prize of collaborating with Simon to solve a puzzle. I think it's really interesting. So do check it out. What else has been going on the chat? I mean, also on Patreon, crosswords and connections videos. Plenty of those. Lots to enjoy. And those links under the video also include the way to Discord, our Discord server, or how to send us snail mail. Some people do, very kind of them. But anyway, thank you very much for watching the channel, for spending your time with us. I'm going to go through the rules of quite a long title today. I remember that when people first started sending us puzzles, the titles were often quite long. Then after that, we've gone to a phase of quite short titles. And the way I'm gauging this is because when I edit the video, of course, we put the title up above my head and the rule set. And I used to have to regularly use 2 lines for the titles, as today. But for many of the videos in the past 2, 3, 4 years, the title is very happily sat on 1 line. But when it's carefully balanced weights and measures by Half-Baked Lunatic, it's not going to go on 1 line. Anyway, what are the rules of carefully balanced weights and measures? Normal Sudoku rules apply. That's going to be 1 to 9 in every row, every column, and every 3 by 3 box. Box borders divide the blue region sum lines into segments with the same sum. So I can see a 5-cell line here. That breaks up into a 1-cell bit there, a 2-cell bit there, and a 2-cell bit there. Look at those box borders dividing that. And so each of those 3 segments is going to sum to the same total. Now, a gold palindrome line, so here's one of them. This one is, I can't even count, 9 cells long, I think. That has to read the same forwards or backwards. So it's a very simple pair of rules. However, identifying where the lines are is a little more complex. I'm a little surprised that with yellow and blue, they don't look a bit more green when there's in the parts of the lines that are both. But there we go. They don't. To me, it's clearly blue and clearly yellow. And Half-Baked Lunatic has been very sane in making sure that the blue is thinner than the yellow. So you can always tell where the lines are. Anyway, that's enough rambling about that. I'm going to start now. Let's get cracking. I have no idea how to start. With a lot of palindromes, and there are a lot, this could very much be a colouring exercise. But that's not normally the case with region sum lines. So just going to briefly have a look at this one. That is 8 cells playing against 6 cells of blue line. Now, 8 cells adds up to somewhere between 36 and 44. There's 1 cell missing from the full set of 9. We know what the full set of the 9 digits add up to. I'm sure even you do. It's 45. So take one of those digits off and you get 36 to 44. Now, 36 minimum, what can these 6 cells add up to? I mean, it's somewhere between 21 and 39. So now we've restricted the n for this line to somewhere between 36 and 39. Okay, and that's going to leave this digit being the difference between 45 and somewhere between 36 and 39. So somewhere between 9 and 6, but it sees a given 6, so that is 9, 8, or 7. And the n is now 36, 37, or 38. So that group of cells adds up to 36, 37, or 38. This group of 3, therefore, adds up to 9, 8, or 7. I'm deducting from 45 for box 2 again. These cells add up to 9, 8, or 7. And 2 of them add up to that one. Okay, that doesn't tell me much about that one. Now, I am probably missing the point here, where we're probably meant to focus on the palindromes a bit more. Actually, yes, where is the middle of this line? So there are 8 cells there. From the other end of the line here, 1, 2, 3, 4, 5, 6, 7, 8. Right, that is the middle digit of the line. So those 2 have to be the same digit because they're the other side. Right, let's colour away on this line just to see where we get to. I might undo this colouring if it turns out that it's not the best colouring to do, which may well be the case. Let's go red there. I've got it wrong, haven't I? I must have miscounted. No, I've missed out a digit. That's what went wrong there. That one was green. Right, this one was, I didn't miscount, I just missed a digit when I was colouring up. Okay, so this is going better now in terms of me hitting the right buttons. Then we could make that grey. Yeah, these are the 8 different colours in box 1. I could colour that the 9th colour, which is the darker green. Not very dark in my palette here, but anyway, in fact, that's the only one. Maybe I am going to slightly change that, make it a bit darker. Is that too dark? Probably is. Let's go there. Okay, so I'm going to make that the darker green. There we go. Now, this is the middle of the line. It doesn't have a repeat digit on the line. Does this tell me anything doing this color scheme? It does tell me one thing. Pink and bright green have to be in these 3 cells because they can't again be, and the same is true for light blue. Oh, so I'm going to find out what this is. These must be pink, light blue, and bright green. This one is, oh no, not orange. It's dark blue. Now that's on a palindrome in the 3rd position. That's this palindrome, so that one is dark blue. I don't know. I may be approaching this puzzle in entirely the wrong way. There is every chance. Okay, what is this? It's not any of those or any of these. What's left? The 2 greens and orange for this digit, which is the same as this one. So it's the darker green or orange. That's not quite as decisive as I wanted us to get. In this box, we've still got yellow and grey. In fact, where is the center of this line? Those 2 are the same. The center is not a cell, it's a gap between cells. So those 2 are the same, those 2 are the same. And therefore they must be from this group, yellow, grey, or dark green. Which are the, okay, one of them is yellow because by Sudoku one of these has to be yellow. And so that's also over that side of the line. Okay, it's becoming borne in on me that this was a very, very flawed way of going about this puzzle. Okay, let's look at this cell, which is the sum of those three by the region sum rule. So that's 9, 8, 7, or 6, and these add up to that same digit. Now, where is that on the palindrome? It's there again, right? So it's 9, 8, or 7, and it's the sum of those three. Those two digits are the same as those two, so they have to come from this group. Oh, and there are 4 cells here matched against 7 on the region sum line in this box. That's quite different. So the most these can add up to, 9875 is 29. The least these can add up to is 28. Oh, that's really interesting. Right. This 4-cell line either adds up. So I know that the minimum for this is 28 because 1 to 7, the triangular number for 7 is 28. I know that they add up to 28. So this either adds up to 28 or 29. I know the maximum for this is 29 because with the 6 gone, 9875 is the most you could achieve here. So this is either 9875 or 9874. This one is either 1 to 7 or 1 to 6 plus 8. And that means the missing digits from it include a 9 in one of these cells and either 8 or 7. So one of them is a 9. Now I've got a 9875 quad, and 9 can't be over here. So 9 must be in one of those two cells. And on the palindrome, that means 9 must be in one of these two. That's interesting. I have a feeling I'm going to end up unwinding all the colour in the first 3 rows, etc. Now, if this was 9874, that would be the 4. This would then be an 8-7 pair. Okay, this can't be 9874 because this 5789 quad is needing a 5 over here. So this must be 9875. That's not a 4 or a 5. And then the n on this line is 29, and that means these digits are 1 to 6 plus 8, and these two are 7 and 9. Now 7's in one of those cells and not in these two, and now 8 is not in these cells. They are a 7-9 pair. They're on the palindrome, making these two a 7-9 pair. And this is on the end of the palindrome, making that a 5 or an 8. And in fact, we've got a 5-8 pair in the column now. Got a 7-9 pair in that one. These digits. Now, if that was a 9, you couldn't use a 5 or a 6. They would be 2, 3, 4. If that's a 7, they're 1, 2, 4. So 2 and 4 are definitely in those, along with 1 or 3. And the other one of 1 or 3 is sitting there in the box. Okay, well, that's good progress. Now, I haven't thought about this palindrome at all. It's got 4 cells there in box 8 that are matching the 4 cells that are not in box 8. This one has 3 cells there that are matching those 3. I was about to say, oh, they can't be 7 or 9 then, but that was obvious from both boxes. Wonder what is obvious in this puzzle. Nothing is obvious to me about how it works. I'm lucky in a way I stumbled on the 4 against 7 thing down here because I could easily not have noticed that for a long time. 5, 8, 7, 9, 4. The other digits in the bottom row are 1, 2, 3, 6. And one of those is here. Okay. This digit is the same as that one, so it's orange, red, or yellow by the earlier color scheme. That one is the same as that one, so it's one of these colors, and so is the 5 or 8 digit. That's difficult to torture into any kind of shape of meaning that benefits me. Those 3 are these 3. This digit is the same as this one. Is it worth looking at the colour scheme from earlier? Okay, I mean, this might be absolute madness. I'm going to say that's yellow, red, or orange because it has to appear at the top of column 1. This one is one of the two greens or pink, and so is this one, which also appears in that group. Now, I don't know how else to use the information. This digit is the same as this one on a new palindrome. They're the ends of a palindrome. Well, they can't be certain colours. The two blues and grey, or red or pink. So they're a green or a yellow or an orange, these digits. One of the two greens, or yellow or orange. No, that's not a useful approach. Those two are on this region sum line. No, I was going to say that those two, they're these two digits. No, that's not useful. This is a palindrome digit with the number here. That palindrome goes all the way to the corner. So in the top row, well, yellow is in one of those cells, so we are a bit limited on what colour this can be. It could be red or grey, but it could be either of those colours. Oh no, it couldn't be orange. God, I don't know. I'm really struggling to relate colours to numbers in any useful way at all. I've got to think of something I can do here because I'm not getting on with this. That has to be there. These three. Well, that digit is the same as that one on a palindrome. These two are the same as each other as well. Just don't know. Okay, let's think about this region sum. So if that's a 7, this is a 1, 2, 4 set. And then this is 7, and this is 9. If this is 7, we've got 38 here. Then that's 30. Oh yes, this has the same total as those three. What of it? No, I don't know that either. These two are the same as these two. That's not useful, I don't think. No, I'm some way away from making any actual other connections. It was nice to get these cells narrowed down, but I haven't really achieved anything else after that. 5, 8. No, I was going to say both of the 5, 8s. Well, they can't be red, orange, or yellow. Even this one can't be red, orange, or yellow. So this 5, 8 could be the third colour up here, or it might be one of those. These three add up to 7, 8, or 9 and include those two and this. These could add up to anything between 3 and 8 as far as I can see. Wow. I mean, there are carefully balanced weights and measures here, I'm sure, but I cannot work out how they go together. So I need to think of something cleverer, something bit more holistic, that's interesting and going on. Like these three in this column are the sum of these three by region sum rules. What does that mean? Does that mean anything at all? No. Oh, this one. Did we know? No, it was grey or dark green, wasn't it? Then it has to appear in one of these three cells. No, I don't know. I think I may have started in the wrong place with the colouring, which was kind of what I feared earlier. But I don't know how to relate these numbers across the various sections of the grid. It is tricky, this. Please bear with me. Blue is there or there. So blue couldn't possibly be 7 or 9 because it would have to be in one of those cells and therefore can't be 7 or 9 down here. That's not very interesting. However, okay, let's try something else. 5 and 8 are in these two. And that is one of 5 or 8. This digit, where is that in box 4? One of those cells. Wow, no, I don't know. I don't know. So pleased to get get the N on this line, and it's done absolutely nothing. Oh, okay. The other thing I was thinking about, so we know that the N on this line adds up to 29. And that is the sum of these three cells, which are the same as those three, and the other 4, which are the same as the sum of those 4. Would that be any use, knowing that this 7-cell highlighted region adds up to 29? I don't think it would, and doesn't have any repeat digits because they're all the same digits that appear in box 8. Don't know. No, I was then going to observe that these three, no, they add up to the same as those three. That's not quite the same as being the same digits. They're not palindromically related. Goodness me. Goodness me. Okay, I don't quite know where we are here. I don't know. Right, I've got those two are the same as these. So in fact, that digit is the second one. That is 1, 2, 3, or 6. I mean, I can't see the value in noting that. But you never know. Maybe I will. Those two are the same digit, so they're one of these three. I don't know. The way that Sudokus go together is very carefully organized, but it's not really helping me in this case. Okay, here's a tiny thing. Those two cells add up to the same as those two, but they can't be made up of the same two digits, or those two would knock that digit out of that cell. So this couldn't be 3 or 4 as a total of these two, because then there'd only be one way to arrange them. We also know that these add up to no more than 9, so these add up to no more than 8. And this is bounded at the top end by 8, and it's now bounded at the bottom end by 5. So that is 5, 6, 7, or 8. It is the really most minimal thing. That does appear in this cell on the palindrome. If it was 5, we'd know this was a 1, 2, 3, 4 set. If it was 8, we'd know that digit would be a 1, and this would be a 9. That would be really quite interesting. That digit is the sum of those three, but this one is the sum of those two. So this can't be dark green, it can't be the same. So that is now definitely orange, and that's quite interesting. I could fill in 5, 6, 7, 8 in all the orange. Now, does that tell me anything over this side? Probably not, but let's just do the thinking. These three are yellow, grey, and dark green in some order. Wow, I mean, it's nuts, this puzzle. I do also know that that dark green is higher than this orange, because the orange is those two cells according to the blue line, and the green is those three according to the blue line in boxes 1 and 2. One of these three is orange, and they're on a palindrome. Well, it could be here if orange was a 7. Otherwise, it's in one of those two as well. Now, if orange was in one of these two, where's the third orange in column 7, 8, 9? It can't be in those two cells because they're here and here in column 9. So it would have to be there. That's quite interesting. If orange was there, i.e. because it was in one of these two, it would have to be a 6. Because it's from 5, 6, 7, 8, but it would also be here from 1, 2, 3, 6. The only overlap's a 6. So if orange is in one of those two cells in column 6, it's a 6. And if it's there, it's a 7. So orange is 6 or 7. Well, that's information learned. And that is the sum of these two. It makes this digit, which is the sum of these three, but also the same as that, into somewhere between 1 and 3. And that digit is here on the palindrome. It's either yellow or grey, I reckon now. Okay, what's this? This is either yellow, dark green, or grey. I wonder if there was a reason grey couldn't be 9. If grey was 9, that would be 9. That wouldn't be, but that can't be grey. Right, grey in two guises sees 7 and 9. So grey is not 7 or 9. So that digit is not 9. And this isn't grey. This pair is yellow and grey. And this is dark green. And that is 9. Wow, that is a hard one deduction. But look, that comes down to here. That's 7. That's 7. That's 9. And that's 9. And those two last ones are dark green, definitely. And these ones are not. These are 5 or 8, and they're pink or bright green. That's so weird. I'm actually glad I changed the greenness or the darkness of the green. Dark green, 9, is in one of these two cells. Well, it's not there, is it? It's got to be here because it's 9. Crazy, this puzzle. That's looking down here. That's a 7 and is one of these colours. Well, it's not yellow now, 7. And it's not orange. 7 has to be red. Oh, that's a discovery. That's a discovery. I don't think I've gone about this in the right way at all. But now orange has to be 6. And that really means something. Now, where did I learn about 6 from? 6 has to be in one of these two cells. One of these is orange. And on this palindrome, well, that's now not 6. That's 1, 2, or 3. But on this palindrome, one of those two is that 6. And then 6 can't be in these cells because of the palindrome up here, so it's down here in the bottom row. And what colour is 6? Orange. Right, of course, that tells us that this is not 6. It tells us that this one is. And look, I can even put 6 into box 4 there. And therefore, I've found the last 6 in the puzzle here. 6s are done. Oranges are done. 7s We're getting along quite nicely with 7s. We want 1 in one of these 2 cells. We also want 7 in one of these 2, a red 7. You know, it makes me think that it's very likely, yes, okay, this can't be 7 because its palindrome equivalent is there. So this is 7 and its palindrome equivalent is there. Exactly what I was thinking was likely. So those 2 are red in tooth and claw. Now, one of these 2 is 7, but it can't be there on the palindrome because that would be here. So this one is 7. And the last 7 in the grid goes in there. And 7s are done. Now, how about 9s? Because we only got a few done. There's a 9 in one of these 2. I'm using the colours to an extent to figure that out. There's a 9 in one of those. If that was a 9 on the palindrome, that would be a 9. That's very plausible. Oh, this is a 9 by Sudoku. So one of these 2 is a 9, and on the palindrome, their positions 2 and 4. That's here or here. Well, it can't be here, so that is a 9 in position 2 on the palindrome. And those 2 go dark green. That's not a 9. And yeah, that can't be a 9. That's a 9. We're done with 9s as well. And we know these 2 add up to 6 and these 3 add up to 9. That's the early work that we did. So this digit is a 3. I don't know its color, but it is a 3. It is yellow or gray. Indeed, that is now yellow or grey. In fact, these 2 are the equivalents of those. So as soon as I found that that pair was yellow and grey, I should have known that pair was. That's fine. Don't worry about me being a bit slow. This, right, 6 has 2 ways of being made up. 1, 5 and 2, 4. So that is a set of 1, 2, 4, 5. I don't know quite how that works, though. 9, 7, 6, 5, 8. Oh, 7 there. Right, that's a 1, 2, 4 triple, and this is a 3 down here. This is yellow or grey according to my colour scheme above. So I might as well fill that in as yellow or grey. And that's going to mean there's a 3 in one of these 2 cells. Oh, I was going to look at this line, this blue line. Those, well, there's a 7 on both sides of it, and then those 2 have to equal the same as those 2. But they can't be the same pair of digits. First of all, because those 2 and those 2 are these 4 on the palindrome, so they're all different. So I suspect there are easy things to do, but I don't know what they are, so I'm doing the difficult things instead. I'm saying these 2 add up to the same as these 2. The difference between those is 3, 4, or 5, so that must be the same as the difference between these. This is therefore 1, 2, 4, or 5. Can't be 8 because we'd be up to 14 here. 9, 6, 7, 3. This is going to be 4, 5, or 8. Can't be 1 or 2 because we wouldn't get to the right total here. Okay, that wasn't actually all that helpful. This pair adds to 6. We know that. Come on, let's just do colours. I haven't done colours for a while. How's yellow going? One of these is yellow. I was going to say is yellow 3, but I don't know that yellow is 3. Grey could be 3. These 2 digits are those 2. Oh, and one of them is 1 or 2. Well, that's that one. And those 2 are the same colour and must go in one of these cells. So it's got to be that colour there. It's bright green. Okay, well, that's good. This is now not bright green. This 5 or 8 is pink. So pink is always going to be 5 or 8. This bright green, can we do anything more with that? It's in one of these cells. Well, one of these 4 cells, which add up to 6 twice, contain both 1 and 2. So the bright green is in those and not out here. And the other of these is 4 or 5. It's a bit difficult to use the info again. Yeah, I don't know whether this is 8 or 5. I just don't know. Okay, 7 and it's 1, 2, 4. That's kind of resolved. This is the other one of 1 or 2. Do I colour that? No. Because again, I just don't know enough about it. I need to do some other region sum equivalence. I mean, I've got that 4 equaling this 3, but that just seems so variable. Oh, I knew that. No, I know that those 2 add up to 6. That's not actually going to help. If they were 5, 1, that would be 8, 2, and 4. That would be 4, 2. That would be perfectly reasonable. If this was 2, 4, that would be 1. One of these would be 5. Yeah, that's not doing anything. I need something new. That's annoying. Right, these 2 are the same color because they're on a palindrome across the middle of it. Now, where do they sit? They sit in one of these cells, but they can't be orange or red. So those 2 are either grey or that thing. Okay, how about these 2 being the same on that same palindrome? That's ruled out of those cells. These 2 can't be red or bright green either. So they have to be blue or that thing. So either all these are the same or these 2 are dark blue. Again, I don't... Oh, look, this. Oh, these 2 are the last 2 colours in this column. They're yellow and... what's missing? Dark blue between them. And those on this palindrome are these 2 cells. Right, well, that one has to be yellow and that has to be dark blue. Suddenly it's very straightforward how to do that bit. Now, yellow there, this colour must be yellow. And 3 is now yellow. And the other digit up there is grey. Okay, 3 is yellow, so I can write 3s in those cells. Take it out of there, that's good. I don't know which one of these is yellow yet. That's not resolved, but can we do a bit more? One of these 2 is a 3. This one on the palindrome would be there. That's quite plausible. Oh, this one, if this was 3, that would make one of these 2 cells 3, but they're here or here on the palindrome, and that wouldn't work. That wouldn't work in either case. So this one is not 3. This is the 3 and is yellow. And on the yellow, I said, and on the palindrome that goes there. And that means this is not yellow, and this is yellow, and it's 3. There we go, 3's all done. It's funny how this is still kind of quite hard work. I didn't expect that at all once we got going. That digit is 1 or 2, we know that. Ah, well that's good, because that has to be here in box 4. And then in one of those 2, but this palindrome won't let it be there because that digit is the same as, it's the 3rd position, is the same as that. So this can't be the green, the bright green 1 or 2, which must be here. Now, is that one of these 2? Oh, that is on the palindrome in the 3rd position. That's here, yes. And that must be here in box 7. I don't know whether it's 1 or 2, but I am positioning it everywhere in the grid, and I'm going to finish with getting it in this cell. Now, that must go with 4 or 5 in this pair that makes 6. And then blue and grey, dark blue and grey are also a pair of 1 or 2 and 4 or 5. Ah, yellow. So I'm looking at this region sum line. On this side, it's yellow and dark blue and that. On the other side, it's yellow and dark blue and that. So to make the same totals, that must be grey as well. That gives us grey here. Grey's in one of the... Oh, this is on the palindrome, so that's grey. I thought that was going to finish grey. Grey is 1, 2, 4 or 5. Oh, that doesn't tell me which of these cells it's in. It should do in a way, but it doesn't. Also doesn't tell me which of these cells it's in. Oh, bother. Right, now we learnt long ago that those two add up to the same as these two. Just haven't used it yet. I don't think this can be 1 or 2 because that's 1 or 2. So the difference between these is now 4 or 5. It could be 6, 1, 2, 5. Or 6, 4, 2, 8. Right, 5 won't work here because we can't get to 11 this side. 4, 2, 8. 1, 2, 5. How about 2 there? 2 won't work there because we can't get to 8 this side. So this digit is 1 or 4. That's really strange. And this one, it's either 6, 1, 2, 5 or 6, 4, 2, 8. This is always 2. That's so strange to get something like that at this point. This can't be 4 anymore. I'm trying to emphasize the last digit. So we got a 2 there. Right, this pair adds up to 6. This is a 1, 5 pair. That purple digit now is an 8. And that is not purple or pink, therefore. This one is and is 8. These two are 8s. This is a 5 in the corner, which is either grey or dark blue, and I still don't know which. This is a 1. That becomes a 4. Now these two add to 10, making their whole line bit add to 17. So this is an 8. And 8 we know the colour of. I mean, this is a very complicated puzzle to do. That's 8. Oh, I could have put that in for ages. Anyway, this is 5. This is 1. That now must be 5 in the box, and that'll tell us that grey is always 5, and that dark blue is always 1. This digit is a 4, isn't it? This light blue has become 4. Okay, so let's fill in those light blues. There's quite a lot that can only be in one place now. I think that's all the light blues, and we're going to make them all 4s. And this digit is an 8, and I know its colour is pink. This is a 1, and it's blue. And there we go. I didn't colour these two last 5s, which are grey, but we got the grid completed. Oh, sorry, I did want to love the puzzle because that is appropriate. It's very clever. There we go. 38 minutes to solve that, and total amounts of confusion throughout. It is carefully balanced, but it was very hard to work out the balances, and I'm sure I did that in one of the most inefficient ways possible. So I'll be very interested to know if people were far quicker or in some cases far slower, because I found that really tricky. But at least we got to the right solution, which is always the goal. And it literally just makes me happy every time. So thank you very much for watching, and we really hope to see you again soon on Cracking the Cryptic. Bye for now.